Screen is shared. It looks good. That's what we're doing today. Knock on wood. Homework is just handed it back. That's done. Any outstanding homework? Have it done for Friday. Just a reminder. Yesterday's work. General form. Here are a couple of questions that we can do together. That's right, Peter. Yesterday's work, not the day before. Looks like this. General formula for a line. Just a couple of warm-up questions. First one's going to look like this. Draw a graph of, or first, find the x and y intercepts of this line here. 7x plus, what would be good? 14y equals 21. So let's do that one together. Break out your pen, pencil, brain, please. I forgot my Arabic book. Tomorrow. Yo, yeah, you remember this type of question from yesterday?
Less than x, so 7x plus 14 times 0.
That's the idea, yeah, times 0 and all that stuff. That's right. Yeah, we'll warm up with that. I'm going to pause the video. We don't need to eat up. Pause time. So pausing the video to resume in a couple of minutes. And so we're back with the solution here, right? So the first step to do, or one step to do, is find the y-intercept. And to do that, yes, from what I heard from class, you let x equals 0 in our starting equation and then solve for y. That's exactly what happens. Now, yesterday, we started with the x-intercept instead, only because x comes first and then y afterwards. Okay, so not wrong, but different from yesterday. Okay, so we will do this. The next step after this one will be, yeah, exactly. So you can see the parts just switch out, right? And so you get the x-intercept there at the end. Doodle marks just to say, same thing comes down right that. Okay, perfect. And once we have these two intercepts, usually we can graph them, right? And I will when I give the answer, but for this one here, all it asks for were those two intercepts. Okay, so let's find them and complete this question here. Okay, so everything you said was correct. Just a matter now of doing it and making it look good. So the first is for the y-intercept. Let x equal 0. So that means our equation is going to, instead of x, we're going to have 0 in there now, wherever x was. Okay, so x is gone. Don't forget, it stuck around yesterday. Okay, it's actually substituted. It's replaced. 14y stays. 21 is what we're looking at. Okay, and so working this out, we'll get 14y is equal to 21. Breaking out the, I guess it's a middle step. 21 over 14, okay? And then your math brain should hopefully be like, 21, 14, I see something. right? No. Close, 3 and something. Okay, so we can go back really to our first section, right? 21 is 3 times 7. What's 14? Yeah, 2 and 7. See? So those can divide out. And we get this is our value for y. And I think I wrote now yesterday, which is kind of nice actually. Okay, so now what do we have? We have our y-intercept. We know it's going to be 0 and 3/2. Yeah, okay. So any questions about that one? No, okay. Same style for x-intercept. Yeah. That's going to look like this then. We're going to let y equal 0. Yeah, question? Oh, question about where do you put the 3/2? Yeah, I'll show that after. Because this question here is just find the intercepts only, right? So I'll answer that first and then put the extras on after. So for the x-intercept, you let y equal 0. So that means the x stays, which is good. That's what we're going to solve for. And the y gets switched out. 21. What's the next step? What do we get? Yep, officially plus 0. We could leave that off if you want, but yeah. Yeah, I'm going to wrap it down around here. So therefore we get 7x is 21. Mm-hmm. Yeah, over 7 is better. Solving for x. Yeah, we could, you could split the 21 up like before, 3 times 7, but really no need. Just write down what you get. X is equal to 3. And so now, what do we know? We're looking for a point. That's what the x-intercept is. Yeah, 3 for the x, 0 for the y. This is now the x-intercept. Oh, intercept like that. True, true. Okay, so that answers the question. So up to that point, anyone need some help? No? Okay. Now to put these on a graph. So is usually the next part. So I could put that as number 2 as our warm-up. Graph the points, the very same ones. 3, 0, and what was the other one? Oh yeah, 0 and 3/2, right? Okay. 0 and 3/2. Here we go. XY axis. Remember, we'll draw the, oh, we got to draw the dots first. Too bad. Yeah, yeah. Okay. Looking at this point here, the first number represents what? For sure. And the second one represents y. Okay. So then with this point here, where are we going? Left, right, up, down. Okay. It's plus 3. So it goes to the right by 3. 1, 2, 3 in the positive x direction. That's true. And then up or down or Yeah, nothing actually. Doesn't go up. It's not positive. Doesn't go down. It's not negative. Just stays. Okay, so it stays right there. That's this one. This one over here. We always start at the origin here, by the way. Origin 0, 0, even though it looks like an owl, right? Starting there, and then we're going different directions. Left or right? It's a trick question. Nowhere. Okay. If it was positive, then it's to the right. If it's negative, it goes to the left. 0, nowhere. Okay, we're not over there. We're not over there. We're going to stay here.
For me, I thought like for the line, like which line should be this
Yeah, well,
this line.
it's not. It's none of them. It's right in the middle. That's the answer. Now, yeah, the question is, what is this thing, right? So it happens to be, well, it is 3 over 2. You can see that. If you want to figure out where it's located, there's a couple of ways to do that. One is to, I think the nicest way for now is to change this to a decimal. Yeah. So, or a mix, let's do it like this. 3 over 2. Where is that located? What we'll do is we'll change it to a mixed number. So that's going to look like this. Mixed number. Here's what you do. How many times does 2 go into 3? Goes once, right? Okay. That gets a big 1. How much is left over? Fine. Yeah, eventually a half. Yeah. 2 go.
Hello.
Hello, Adil. Welcome.
Thank you.
The earlier stuff is on video for you to check later on, okay? Just some warm-ups for now. So 2 goes into 3 one time, but there's a little bit, how many are left over? Just one of them, right? Okay, so it's 1 out of 2 that's left. So it ends up being a half. Okay, so you're right with it being 1.5 there. Okay, so where is it on here? Well, you go, it's going in the positive direction, so we're going upwards. It goes up by 1. 2 is there. It goes up by 1 and then a half. That's how you read it. Okay, it goes up by 1 and then a half. So if it goes up by 1, it gets, starting here, it gets this far. But if you want to go up another half, it goes not to 2, that's too far, right? It goes to about there. Okay, halfway in between. So that is where that point's going to be located. Does that help? Yeah, good. We'll get probably some homework to check then, eh? 7 over 5s, 5 over 7s and stuff. Yeah, okay, well, we can do that. Okay, to finish it up, oh yeah, it does say graph, so like yesterday, still haven't brought a ruler. Put it down, best as you can. There it is. How's that? Yeah. Let's check a couple of these then before we go on to today's topic. Just some more graphing things. Make sure we got these fractions understood. So warm up number 3. Graph these points. I'll say 5 over 2 and 0. graph the point 1 and still over 2, 7 over 2. That's good enough. Just those two to start with. Parser, you got some stuff to do if you're okay with this? Yeah. Boom. See it like that, right? Part C over there if you want. Yeah. Peter, how are you doing? You finished your stuff from a couple days ago? Okay. Over there, I didn't put it out, is the extras. So yesterday's homework will be over there. You can pick it out if you like. Yeah. I can't see. 25? 26, I think. Today's 26, is it? Geez, there it is. Yeah, perfect. Day 25, perfect. Glad you're organized. Keep us all organized. Okay, that's good. So this one, good people, where are we at? You're just looking at me. How about you look at this? What do you do? What? Oh, there's still halves in there. Okay, so let's watch. How many times does 2 go into 5? See, such an easy question. It goes 2 with how many extra? Half. Or 1. You see? 2 times, this will help. 2 times 2 is 4. Plus 1 is 5. That's how it fits together. Okay. So this changes to 2.5. 0 is 0. So where's 2.5 gonna, this 2.5 gonna be? Up, down, left, right? No, it's more than 2. Yeah, $2 or $2.50. Right? $2 or $2.50. It's more. So between what and what? And 3. Yeah, exactly. Okay, so we're on here, up, down, left, right? Zeros in the middle for sure. Don't, because it's first, it's to the right. X is first. So that means left, right is first. Okay, so yeah, it goes over by 1, over by 2, not to 3. Halfway in between. Up or down? No, stays. Okay, so that's our first point there. On location. The next one. Similar in style. Similar thoughts. Yeah, the 1 is going to stay for sure. That's no mystery. But yeah, how many times does 2 go into 7? It makes 6, but it goes in 3 times, yeah? And then how many are left over? Because 1 on the top, the number there 2, so it's a 2 down there. And then we can check. 2 times 3 is 6, plus 1 is 7. That's what we got. Okay, okay. So now how do we get there? We're in the middle. Where salamander is. X1, yeah, goes to the 1 in the X direction there. That's true. Then up by clearly 3, yeah. So we go here. Then we go 1, 2, 3 and a half. It's not all the way up, and it's over here somewhere. Lined up with the 1 nicely. That's a 4, that's a 3, so in between. Okay. That looks good. Let's try. Could you make start to finish? Can you create the graph of? Okay, so fourth warm up and last one. Create the graph of minus 2x. Whoops, that's a y. Plus 4y is equal to 12. Start to finish. Yeah, nice. From class, we got the y-intercepts again for sure. X-intercepts. Yeah, let's plot them in graph. Okay, that's exactly what you do. So you can see our solutions in the beginning were very big. Lots of talking, lots of writing. Now watch. Said y-intercept first. Fine. X-intercept next. What was after that? Yeah, I guess we can graph. We got to watch our directions though. So I'm going to put our check signal beside it there. And then, yeah, connect the dots at the end, right? Okay. All right. So then y-intercept first. What do we do? Exactly. I'm going to put this in here. Let x equal 0. It's kind of professional. Shows what we're doing. Describes what we're doing, rather. So that replaces it. Yes, that's a 4y there. Equals 12. And so what happens? What do we get?
How it equals 12?
From Zoom, we got a question. How is it plus 12? Given in the question. We don't have to find it at all. I gave it to you. This is what we have to, this is the equation that we have to make the graph of.
Yeah, but yeah, how it become 12?
Oh yeah, I'm saying like, this is a new question. I give it to you for free.
Mm-hmm.
Okay.
Okay.
So we got a 12 there to start with the question, and then we just copy it down as we do the work along. Okay. What we're doing in this step, let x equal 0. So replace x. From class, yeah, we get a 0. We could put the 0 in. Want to put this 0 in or skip it? Yeah.
Okay.
Okay, 2 times 0 is 0. So we're just going to skip it, okay? So we'll get 4y is equal to 12. Yeah, let's shorten up these answers a little bit. Y is equal to, yeah, good.
Oh yeah.
You're lucky I gave it to you.
3 times 4,
4 over 12 is, I don't know. Yeah, 3. Good. So we got, oh, no room for the now, but we can put the now.
Okay. Okay, got it.
Now x is 0. 0 and 3. So that's for the y-intercept. That's the first one we did. Again, out of order from yesterday, but not wrong by any means. Okay. I'm going to mark that though. Just so we don't lose it in the green. Yeah? Yeah. What's next? True indeed, right there. X-intercept. We let what equal 0? No, 4 doesn't equal 0. 4 times 0, yeah? So what are we letting equal 0? No. It goes beside 4. What's beside 4? Oh, why? Because I want to know. All right, so You let y equal 0. Okay. I know you know what you mean, but just tighten it up a bit there. Let y equal 0. What does it look like? Put his, yeah, plus 12. Yeah. Okay. That's true and good. So we have our 4 times 0 over there. Yeah, we get minus 2x now is equal to 12. Fantastic. Yeah, the clever answer, 12 over minus 2. And now what is the answer? Yeah. I'll put so we get x is equal to minus 6. And then now, just so it's have a difference there, minus 6 and 0. Zoom, I heard you. You had something to say.
Yeah, I'm just going to say the 6.
Oh, perfect. 6 negative.
Yeah,
Don't forget the negative. Right on.
yeah.
Okay, question from class. Go ahead. Yeah. No, it whichever one works for you. Doesn't matter at all. No. I said yesterday I started with x because right, x coordinates first. Yeah, that's right. Dunya seems to have a different idea. Gave the answer last for the last question. Why was first? She spoke up first, right? So we'll do it this way. No problem. Doesn't matter at all. As long as you get all the steps here, looking good. Checking the work. What do we have at the end here? We have 2 points, and now we can put them on the XY axis and we're good. Okay, so the 2 points we had were 0, 3 and minus 6 and 0. Okay, showtime. Where does this one go? Up.
In maths.
Well, the first one is X, second one is Y. Oh,
Yeah,
and this is the Y axis always. That's the X axis always.
yeah. So should be in X?
Yeah, Zoom, did you say up?
No, in X, like right 3.
Oh, no. Zoom is saying to the right by 3. No, watch this. The X is always first and the Y is always second. So the X is 4, going left or right. Y is going up and down.
Yeah,
Okay.
so the 0, 3 equals X and minus 6 equals Y.
No, the 0 is for the X.
Oh,
Look up.
yeah. Okay,
The
yeah.
3 is for the Y. Okay, so for this point, we don't go anywhere in the X direction. We just stay there. Don't go over there, don't go over there.
Yeah, and go up by 3.
Up by 3, nice. Right there. Okay, that's our first point. The next one.
Mine down by 6.
No,
Oh, yeah, this X. This is
that's right. This
this
is for the
is
X.
left 6.
Yeah. You know, I remember actually writing this down in an earlier lesson. Let's do that. Write it down. Left by 6, right? Left by, that's English now. Left by 6, right? Confusing. Left by 6, okay?
Yeah.
Yeah. So left by 6 goes 1, 2, 3, 4, big 5 and a 6.
Mhm.
Up or down? No. Middle.
No. Yeah.
Stays there. Okay, so let's do this. Write the English part in, or the language of your choice, but make it non-math. Yeah. Dots are in place. We're good to go. Connect the dots, and you got yourself a line. Congratulations. Yeah. Yeah. Okay. So then where are we at now? Those are the warm-up questions from yesterday, or at least about yesterday's work. Mm. Yesterday, yes. Okay. Now, to get ready for today, well, look back, look book, look back. Could someone help me out? I'd like to fill this page a bit here. What was the style, the equation for slope intercept? How does that look? Exactly. So it's coming back, but not exactly 100% clear, right? Okay, not bad. So from class, we got an answer. Maybe if I asked what this one is, slope point form. All right, that was another style. We also had the general form from yesterday, which we talked about already. So I want to focus on these two. The slope point form, that was the one that I just heard from class. Okay, that's this one. Y minus y1, m, x minus x1. What's the slope intercept? How does that one look?
Y equal mx plus b.
Nice. Class got it first, but Zoom got it very close afterwards. Yeah, nice. That's there. And the general form, just because we had it, was, yeah, all together, and by equals c, right? Yeah, good. Okay, so I just want to do a couple of questions with these ones to get ready for today's. So, first one. Write the slope intercept form for this situation here. Okay, so that's 0 and 5. And this, totally not to scale, we'll just say is 12 and 0. So help me out, good people. What style is this to begin with? Yeah, it's the y equals one. Nice. Mx plus b it is. So to successfully get the equation, I meant equation, right? We got to figure out what m is and what b is. Which one do you want to do first? M? Sure. You can figure out what M is. How do we do that? Mm, no. How do we figure out the slope? Given what we got here. Yeah.
The slope you have to uh, like u y2 over x2 and y1 over x.
Nice. Lots of good answers. We got the final answer over there. Minus 5 over 12, I think. 12 over
Oh,
5. 5 over 12. Okay. We got the formula. And we got the formula. Yeah, that's what we got to check. So it's good to do in your head. Just be super careful with that last bit. I'm going to write it down. Yeah, it's the formula there. Okay. Which one's y2, x2?
12 and 0.
Sure. Nice. Okay, so from class, we got this one. And yeah, usually one's on the left, but not wrong if you switch it. Okay, so we got this. I'm going to put it to the side just for real estate. Y2 is 12. Well, that's a lie. Yeah. What's Y2? I'm gonna trust you instead. That's what I did. It's not 12, even if you say it twice. No. One by one. 0.
0 over 2 over 12.
It's okay, parse it. You and sure if we do the top, yeah. Minus 5. Do the bottom. Yeah, there we go.
1.0.
Saw the numbers for sure. Yeah, thanks, Adil. So we got minus 5 just jumping out right there. Okay, so that's good. That piece, that part is this part here. How about this one? Yeah, why is that? What is the B? What does it represent? That's a B, not a 6, by the way. What does it represent? Yeah, y-intercept, which is at what location? No, even way easier than that. Whew. You're burning off all your chips by thinking that hard. Don't need to do all that.
Minus
B-
5.
Yeah, someone else is saying minus 5. I'm not sure where this minus is coming from. Yeah. Huh? Mm, x minus 0. So there's a minus 5 in there, but it's not the final. You can put it up on the board for sure. Okay. But I'm just looking at this picture, and I know in my brain what the y-intercept is. It's where the line crosses the y-axis. So where in the picture does the line cross the y-axis? Yeah, it goes up from class here, right? This location here. Right there. This is our line. And it crosses the y-axis right at that spot there. So what is the y value of this location? Exactly. Don't count the 0. Oh, you're changing your mind now. Yeah. Right on time. I almost wrote it down. You just beat me. Okay, so the answer is not from class or here in minus 5. couple times. No, +5, just by looking at the graph that's there, okay?
Okay.
Nice. The question is, what do you say it's to show this in writing? Okay, so in this situation, it's given to, that's enough. You can just say from the graph if you want. You know, otherwise I understand where you're getting it from. Okay. Otherwise, if you're given equations and stuff, then we do what we did before. Y-intercept, let x equal 0, all that stuff. Okay, but in this question, we don't need it. What we do need now, though, we got our slope, we got the y-intercept, we got to put these all together. What's the final answer going to look like? Yeah, y
Y
equals,
12 x.
nice. Zoom got the x in there. -5/12 x plus 5.
Plus 5.
Yeah. Just like that.
Okay.
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 All right. Mr. Yo-Yo at the back, you got a question there? Good. Okay. I'll do another one with the slope point, the other style from a couple days ago. Okay. Do you need to discuss? You guys are okay? Okay. And similar in style again. Look back number 2. So for this, right, slope point equation, given the following here. Given 2, 7, and 10 and 8. Let's draw the graph for this one as well, just to make sure that's solid. Mm-hmm. 2, 7. Where's that going to be? Right by 2. Yeah, we'll use our English there. Right by 2, up 7. So try and squeeze it in. How's that look? Oh yeah, that's okay. So right by 2, 1, 2. Up by 7, 1, 2, 3, 4. Big 5, 6, 7. Somewhere about there. This one here. They are, yeah. We need the directions now, though. Nice. I'm going to say R for right, if you don't mind. Right by 10, up by 8. Is that okay? Save me some space. Yeah. Okay, so right by 10. Whoa, way out here then. 1, 2, 3, 4. Big 5. 6, 7, 8, 9, 10. And up by 8, that's a 7. So just one more there. Over across, somewhere like that. Okay, X and then Y. Connect the dots. Okay, now let's get back to the main part of the show. Main part here. Let's find the equation given these 2 points. Oh, good. So from class, we got someone given the style of the equation to start with. Very smart. Okay, looking for this one. Mm-hmm. Mm-hmm. Yeah, close brackets like that. That's good. Similar challenge as before. We need the slope and not the y-intercept, but a point. Oh, nice. From class, we got, so there's two parts to here. We got to find the slope, and we also have to select a point. Class was clever. Did the point first. 2 and 7, right? Remember, when it goes in there, you got to think about opposites. That was part of this. Okay, so what does it end up looking like when it's on the inside? Well, it's a +2 there, so it's going to be a -2 on the inside.
-2.
Yeah, nice. Good work, Zoom. That's true. It goes over here. It's going to be y -2 because it's +2 over there. Equals, until we get it, the slope.
-2.
Whoa, let's be careful. Not be telling lies. I say, speak the truth. Which is the x and then which is the y?
Y7. Yeah.
Yeah, let's speak super careful. Switch that to 7, okay? 7 is with the y.
Mhm.
-2 for the x. True? True. Okay, so we got this. Now we got to find the slope for the situation.
Put them in order.
I'm gonna use the formula. How about that? Yeah.
With y2 minus y1. Yeah.
There's a question from class. I'm not sure what it is though. Go ahead. I think so, if I understand the question. To get the slope, we need 2 points, right? Where are they? Those are them. One of them's x1, y1, the other one's x2, y2. Doesn't matter. Yeah? Okay. So what we'll do is just say,
So 8/10 minus.
let's put the x1 and y1 first as their zoom, and then we'll put it in the formula.
Oh, okay.
Okay, that way we can be careful with, see, I made a mistake with the 2 instead of the 7. That way we can be careful. X2, Y2. Okay, so for Y2, 8 now, right?
Mhm.
Y1, yeah, 7. It's good. X2,
10 minus 2.
yeah. Oh, you guys are lucky. No weird minus of minuses today. Yeah, I kind of forgot. Okay, you're lucky.
Over 8.
So 8 minus 7, what do we got?
1.
True. Hadil, can you hear what's going on in the hallway?
No.
Oh, so crazy. Okay,
And 8.
10 minus 2. Yeah, 8, thanks. Hadil's like, no fun, get down to work. It's like, okay.
No, No. Okay.
No, it's perfect.
But
We need,
because I didn't hear anything what is happening, so
we need it. We got to be serious sometimes. So here's what we got. At the top, y minus 7. All we needed was this, the m, the slope. We got it. We put it in. Happy life. There we go. Final answer. Y minus 7 is 1 over 8 times x minus 2, like that. Okay, takes care of that. So good people, let's take 5 minute stretch. We'll come back for a little bit of the new stuff, okay?
okay. Can you check my work? I have a lot of mistakes, so
Yeah, you know what? Because of the video and all that, I'll have to check it after class. But yeah, first thing today for you.
okay, thank you.
Okay, I'm gonna
Sorry for
pause.
yesterday. I'm
I just
just I
pause the recording for now. For this part here, what we're doing is we're taking a look at, yeah, something called parallel and perpendicular lines. Ahead of time. Does anyone know what parallel means? Or can, yeah, not by the word itself though. Yeah, exactly. Perpendicular, anyone? Yeah. Yeah, exactly. So from class, we got perpendicular. That's an R. Perpendicular looks like when you have one thing going this way, another thing going that way. Meets at, shown with a square box sometimes, 90 degrees. It's true. Super long word. So that's how we show, that's the symbol we use for perpendicular. Okay. Parallel. Yeah. Lines same direction. Ben, what was that? That's true. I think it was on the screen already. They never meet. Fact, that's true. And those are, see, side by side, and they probably have that symbol there as well. Maybe, depends on the question. Okay, and again, to avoid writing that whole word, we just show that to show that they're parallel with one another. The example that was on the screen before where you can see the, whoops, you can see the little lines here on the road. Those are parallel, right? Railroad tracks, parallel with one another, right? Perpendicular, right here. This road is going that way, and then this part is going, that road is going that way, 90 degrees to one another. Okay. Now we got to be able to do, we got to be able to look at slopes from our equations and such in order to figure out if a line is parallel or not. So let's keep this in mind. Same direction, never meet, and at 90 degrees with one another. Okay, so on the screen, official like, parallel lines, yeah, never touch. Denoted by, it's not going to come up on the screen, denoted by this symbol here. Parallel or perpendicular, the other ones, they cross at 90, shown by that. Okay, so watch this. This is when we have parallel lines. So this gets the big star. That means the slope is the same when the lines are parallel with one another. Okay, and we've seen, all right, we've seen the slope in different locations. Y equals mx plus b, the slope point formula, all right? What's going to happen is that if we start drawing lines and put them on a graph, x and y, put them on a graph, check this out. These lines, they're parallel to one another. If we put them on an XY axis, look at this. This y-intercept here is different from this y-intercept down here. The y-intercept there is different from that y-intercept there. It also talks about the x-intercept. So if you extend these lines straight as you can, see this line will cross there at that spot. And this line, wow, off the page. But you can imagine that it crosses the x-axis somewhere over there, right? Different x-intercept. What's the same though when lines are parallel? What's going to be the same for both of these lines? Same slope. Okay. Let's pretend the slope is 3/2. This line here on the top, that can have the equation y is equal to 3/2x. I'm going to make it up. I'm going to say plus 6 for that location there. Judging from the picture, what's the location of this y-intercept? As best as you can. Yeah, I would say this is about halfway, right? I'll call it a 3. So if we know the y-intercept for this line here, and we know it's parallel, we know the slope is the same, what's the equation for this line going to be? Equation for the other one, y is equal to same slopes, right? They're going up at the same angle there. So what's the slope going to be? 3/2, because that's the same. X for sure. Yeah, plus 3, because it has a different y-intercept there, right? Okay. All right, so different x-intercepts. Parallel lines, yeah, they're easy as it suggests. Watch this. Suppose we have the lines written like this. We have y is equal to 4/5x plus 7. Suppose this is one line, and that this is another one. Y is equal to 4/5x minus 8. See, what's the slope of this line here? Four over 5, just read it off. Nice, eh? What's the slope of this line over here? Yeah,
4/5.
nice. Zoom got it as well there, right? So are these slopes the same? Yep,
Yeah.
parallel lines, right? Different y-intercepts, but hey, that's okay. How about these ones? Now, these ones, check out these ones. Different style, right? This was with the slope intercept. Check this out. Y minus 8 equal to 7/6. x plus 2. And y plus 7. 7 over 6, x minus 1. Yeah, for both of them. See the number in front there from the style. The slope is 7 over 6 for both. The first line and the second line. And so these ones are parallel as well. Okay, so that way, that's what makes it easy. If you're given equations, just read them off. Easier. For perpendicular though, this one might take a little bit of thinking. Only a little. To see if lines are perpendicular, two things happen. One, you have opposite sign. And second of all, upside down. And I might add, by the way, that we're talking about the slopes again. So watch this. Suppose we have this line here. Y is equal to 3 over 2x plus 7. A line that is perpendicular to it, remember this one, so that meets at 90 degrees, has the slope, opposite sign, and upside down. So what's the slope over here? 3 over 2. And so for the perpendicular part, we wanted opposite sign, right? So it's positive here. Means we want a negative over here. And instead of 3 over 2, we want it switched, if you remember. 2 over 3. Yeah. Okay. So the perpendicular, an example here would be y is equal to opposite sign minus upside down 2 over 3 x plus some other number, right? Doesn't really matter there. So I'll just say 11. The main thing to watch is that how the slopes are different from one another. Opposite signs, upside down. And as you saw earlier then, there are a number of examples, right, that we can just read off and check, okay? But maybe let's do another one here on paper, on the camera first. Check out these lines. Make sure they are perpendicular to one another. This one here, we got line is y minus 8 equals 15 over 6 x plus 2. Okay, and so to make it perpendicular, okay, we got to check the slope. So we got slope is 15 over 6. And so what's the new slope going to be?
Minus 15 over 6.
Zoom said minus 15 over 6. Not bad. You got part of it there, Zoom. It's a positive over here. So it needs to be negative over here. But there's another part. What happens with the 15 and the 6? What happens with the top and the bottom?
6 over 15.
Exactly. Upside down. 6 over 15. And so just to make it up, we're going to have y minus 6 is equal to, important part here, minus 6 over 15 times x plus 7 there. Okay, so opposite sign. And upside down. Now, it is math class, so instead of talking about upside down all the time, there is a special math word for it that you need to know. And that's called the reciprocal. Yeah, that's the word for upside down. The upside down part only, not the signs, okay? So these, can I squeeze it in at the bottom? Yeah, I think I can, it'll look good. These are examples of reciprocals. 2 over 3, along with 3 over 2, upside down. See that? 7 over 9, upside down. Reciprocal, 9 over 7. This one might seem funny. Negative 2. What's the reciprocal of negative 2? Yeah, minus 1 over 2. There's an invisible 1 down there. So that invisible 1 goes to the top. That 2, the minus 2 goes to the bottom. Okay, reciprocal. Upside down only there. Yeah. Okay, then. Let's go to the screen and see what we got had ahead of time here. Yeah, negative reciprocal slopes. So the negative I'm saying is opposite signs, right? And then reciprocal, you now know, just flip it upside down. And then as you saw a bunch of examples, right? So we have a half here, 1 over 2. That switches to negative 2 over 1, which is just 2 there. Next example, look at these ones, just to make sure. Slopes only there, right? 3 and upside down, reciprocal. 1 over 3, opposite sign. What's that? Minus 3 over 1. Oh, 3 over 1 to start with. This side here, on the screen. Screen versus camera, yeah. Yeah, upside down, reciprocal is 1 over 3. And to make it perpendicular, it's now negative over there. Yeah. Another example, it's minus to begin with for this one. So it turns to positive. Yeah, flips upside down. Question from class? Mm-hmm. So there's a question in class about the y-intercepts here. Changing them just because, no reason. The main thing for here is that the slopes are different. Okay, we could actually, I could draw these out maybe next class, and you can see what the effect of that y-intercept is, but it doesn't affect if things are perpendicular or not. Slopes only. Okay. Let's see, just a second. Let's flip through here, do another couple here. Yeah, today's homework is going to be from here a little bit. Okay. Are these ones perpendicular? This isn't telling you, this is asking you this time. What do we got? Yes or no for this one? The one on the screen. That's right. Need this, the signs there are the same, right? Need the signs to be opposite. We have the reciprocal part. That's okay. But they're not opposites. So if they're not opposites, that means they are not perpendicular to one another. Okay, they'll meet at some other angle. The sign is the, see that's plus 4/3? Exactly. The signs have to be opposite in order to be perpendicular. Okay, it's sort of a math fact for now that you have to remember, but once we start drawing some pictures, then you can see. Yeah. These ones, they are, that's the invisible one. Okay, so imagine one upside down is just still one. See? For this one here, if you have -1, if you do the reciprocal, that's 1/-1. And if you do some calculating, it happens to be the same as -1 there. Okay, so that part's okay for the reciprocal, and they're opposite signs. We got a +1 to start with, and it goes to a -1 afterwards. So these ones are, that example is perpendicular to one another. Okay, how about we leave it there for today? I'll keep this slide up, and have to give you a little few practice questions for today. As I said, it'll be it's going to be odd numbers, questions 1 to 14 from the page that I have here. Okay, I'll put that back up here and update it on Teams as well. All right, so pause the video for now and then take care of all the homework such.